friends, how are you? Welcome you all on the digital platform of Highmarks Academy. तो हमने इस प्लेटफॉर्म पे एक मुहिम चलाई है जिसके अंतर्गत हमने बोला था कि हम क्लास 11th और क्लास 12 की मैथमेटिक्स को इस प्लेटफॉर्म पर कम्प्लीटली अपलोड कर देंगे। तो हमने क्लास 11th में 3 चैप्टर कंप्लीट कर दिए, जिसमें से कौन कौन सा था? सेट्स, रिलेशन एंड फंक्शन एंड ट्रिग्नोमेट्री। वो पूरी तरह से कंप्लीट कर दिए और फिर हमने सोचा कि क्यों ना क्लास 12 के चैप्टर को लिया जाए। तो अब हम स्टार्टिंग करें क्लास 12 के चैप्टर फर्स्ट से। द फर्स्ट चैप्टर ऑफ क्लास 12 इज रिलेशन एंड फंक्शन. What is the meaning of relation and what is the meaning of function? We have already understood in the class 11th, as we have already uploaded that lectures about the relation and the function. What is the meaning of relation? What is the meaning of function? What are the domain, range, codomain of relation? What are the range, codomain and domain of function? Also, we have discussed many kind of relation there. We have gone through the reflexive, symmetric, transitive relation there, and then we have proved what is the meaning of equivalence relation. And now in this topic we are going to study about deeply into the relation. How can we prove reflexive, symmetric and transitive? So there are many questions about that. So we are starting this lecture with the definition of relation, as we have earlier discussed in class 11 chapter number 2nd. So what is the meaning of relation? Just I am writing the definition of relation. Relation means you relate to each other. This means you relating with any other element. You relating with your friend, you relating with your neighbor, you relating with your father, you relating with your mother. There are many kind of relation in your real life. As well as in mathematics, there are also there is a relation between numbers. There are many kind of numbers, and we relate that number by any kind of statement, and that statement is called the relation. So definition of relation is a relation. A relation is what is the relation? A relation is the subset of Cartesian product of A cross B. Subset of Cartesian product A cross B defined by any rule. Defined by any rule. Relation is a subset of Cartesian product A cross B defined by any rule. कहने का means A cross B एक Cartesian product होगा, and relation will be the subset of that Cartesian product, and there will be a statement or there will be a rule between two elements by which we can relate them in a Cartesian product. So first of all, what is the meaning of Cartesian product? Suppose we have a set A, and set A is x1, y1. Suppose I am writing like this. The element of set A is x1. This x is not liking very good. x1, y1, and we have also set B. Set B is given as x2, y2. So what is the meaning of A cross B? The A cross B means first element of A, then second element of B, means x1 and x2. So x1, x2. Then firstly we product the first element of A with by both element of B, means x1, x2, x1, y2. As well as we will do with the second element. Second element is y1, so y1, x2 and y1, y2. So this is a set. What is the meaning of this set? Cartesian product of set A cross B. Now suppose there we use some rule, and by using that rule we are relating only some element of this Cartesian product. Then we formed a subset. That subset will be the relation. For example, I have two sets A 1, 2, 3, 4 and set B 9, 6, 8. So first of all, A cross B, what will be the A cross B? A cross B equal to 1 with 9, 1 with 6, 1 with 8, then 2 with 9, 2 with 6, 2 with 8, then 3 with 9, 3 with 6, 3 with 8, then 4 with 9, 4 with 6, and 4 with 8. Means firstly we find a cross product, or we can say that Cartesian product, not cross product. We find a Cartesian product of A and B. So meaning of the Cartesian product is taking each element of A and do the product with all element of B, then taking again second element of A, do the product with all element of B, taking another element of A, taking product with all element of B. This is the Cartesian product. Now suppose I want to relation here R, X and Y, such that Y equal to X plus 1 or Y equal to X plus 2. Maybe Y equal to X plus 2. Yes, maybe there is a relation, and where X belongs to A and Y belongs to B. Suppose I am taking any element like from A, because X is belonging to A. Suppose I am taking element 1, so 1 plus 2 is 3, but 3 is not in the B, so first one is not coming in the relation. Suppose I am taking X equal to 2, so 2 plus 2 is 4, 4 is not coming into set B, so it is not coming into the relation. But suppose if I am taking 3, so 3 plus 2 is 5, 5 is not coming into the B, so it is not relation. But if I am taking the 4 value of X, so 4 plus 2 equal to 6, 6 is coming into the B. So here when I am putting X equal to 4, I am getting value of Y equal to 6, both are satisfied the sets. That means value of X is coming from the A and value of Y is coming from the B. X belongs to A and Y belongs to B. So the relation 4, 6 belongs to the relation. So there is only one element in the relation. It means 4, 6 is coming on into the relation R, and in the Cartesian product there are many elements, and 4, 6 is the subset of this A cross B. And how we form this one? We form by using some rule, and rule is Y equal to X plus 2. So this is the basic meaning of relation. In the relation, the basic meaning is that we have given some rule. By that rule we find all the elements of that relation, and the relation will be the subset of Cartesian product of two set. Now we have gone through the basic, we have understood the concept of relation, we have understood the concept of Cartesian product. Now we are going on to the empty relation and universal relation. A relation R in a set A, a relation R in a set A is called empty relation if no element of A is related to any element of A. Means suppose there is a Cartesian product not with A by B, but there is a Cartesian product with A by A. Means A cross A. There is a Cartesian product A cross A, and suppose there is not any element of A related with this element. Suppose X belongs to A and Y belongs to A, and on taking any element of X there is no element of Y. In this condition the phi will be the subset of A cross A, because there is no relation, there is no element in the relation. If there is no element in the relation, it means there is phi element in the relation, and phi is represented by this kind of phi, always show the empty relation, and this kind of relation is known as empty relation. Empty relation means there is nothing element in the relation. There is no element. There is no element in the relation. Now universal relation. What is the meaning of universal relation? A relation R in the set A is called universal relation if each element of A is related to every element of A. In this kind of relation, suppose I am explaining you that relation is always a subset of A cross A. But is there any condition when A cross A is equal to the R? Yes, it can be, because as we know that if element of A are 1, 2, 3, element of B are 1, 2, 3, both are equal set in this condition, A is also subset of B or not? This kind of subset is not a proper subset, but this is a subset. So as we know that about the subset, in the subset there can be some element of relation containing in the A cross A, or maybe all element of relation containing in A cross A. And if all element of relation containing in A cross A, in this condition R is equal to A cross A, and this kind of relation is known as universal relation. Now a relation R in the set A is called reflexive relation, transitive, symmetric, or equivalence relation. First one, for the reflexive relation, suppose there is an element A. Reflexive means reflex. And what is the reflex of anything? Suppose I want to see my reflex, then the reflex of mine will be the same as me. So reflexive relation means the element coming in the relation should be same as the relation. That means if the A is coming into the relation, then the reflexive relation of A will be the A. That means AA belongs to R. So if A belongs to R, for every A belongs to A, this condition is known as reflexive relation. Then symmetric relation. Symmetricity means if I am equal to you, then you should be equal to me. Means A equal to B and B equal to A. Means A1 A2 belongs to R implies that A2 A1 belongs to R for all A1 A2 belongs to A. This is the symmetricity or symmetric relation. It means if A1 A2 belongs to R, then the commutative rule apply here. It means the reverse of A1 A2 means A2 A1 should be belongs to the R. This is the symmetric relation. And as you know that symmetricity means if I equal to you, then you equal to me. It means A1 A2 belongs to R, then A2 A1 is also belonging to R. Transitive relation means if A1 A2 belongs to R, A2 A3 belongs to R, and A1 A3 belongs to R, then in this condition all element A1 A2 A3 belongs to A. That means suppose there is a relation A1 A2 belongs to R, A2 A3 belongs to R. If these two conditions are given, then by the transitive relation condition, this A1 and A3 also belongs to R. Have you got it my point? What am I trying to say? This is the relation. Now equivalence relation. A relation R in the set A is said to be the equivalence relation if R is reflexive, symmetric and transitive. If any relation is reflexive, symmetric and transitive, in this condition we can say that this relation is a equivalence relation. It's the meaning of the equivalence relation is that equivalence means the relation which satisfy all the conditions of reflexive, symmetric and transitive. If the relation is symmetric, reflexive and transitive, then we can say that this relation is an equivalence relation. Now we can go on to this topic. This is the determine whether each of the following relation are reflexive, symmetric and transitive. We will try to find the relation is given in this condition are reflexive or not, transitive or not, or equivalence or not. So first one we have given relation R in the set A is given as 1 to 3 to 14, defined as R equal to xy 3x minus y equal to 0. We have given relation R equal to xy in the first one question and 3x minus y equal to 0. Suppose I am putting here the value of x different, I can put the different values of x, but I have to check here that is this relation defined from A to A. I will set A defined as R equal to yes. So first of all I will try to find the relation. So what is the relation? Suppose 3x minus y equal to 0. Suppose I am putting x equal to 1, that in this condition 3 into 1 minus y equal to 0. 3 ones are 3 minus y equal to 0. So from here y equal to 3 means at the value of x equal to 1, y equal to 3. So first one is 1 comma 3. Second one 3x minus y equal to 0. In this condition if I am putting x equal to 2 minus y equal to 0, so y equal to 6. It means 2 6 belongs to the relation R. 1 3 belongs to the relation R. If I am putting x equal to 3, so 3 into 3 minus y equal to 0, y equal to 9, and 9 is coming into the set A, so we can write as 3 9 belongs to R. If I am putting x equal to 4, so 3 into 4 minus y equal to 0, so y equal to 12 belonging to the A, this is coming into the set A, so we can write that 4, 12 is belongs to R. Now this is the last and the final relation. From here we can write as 4, 12 belongs to R. 4, 12 belongs to R. Okay, this is now last and final relation. X equal to 5, so 3 into 5 minus y equal to 0. From here y equal to 15, but 15 is not coming into the set A, so we can't say that 5 and 15 is coming into the relation. That means 5, 15 belongs to the relation. So there are only 4 elements, 1, 3, 2, 6, 3, 9 and 4, 12. If I am putting the value of y is now suppose 1, 3, and now I am putting suppose 3, 1. Is this possible? 3, 3, 9 minus 1, not possible. 1, 3, 2, 6, 3, 9 and 4, 12. When you are seeing this kind of relation, I am writing here R equal to 1, 3, second one is 2, 6, third one is 3, 9 and fourth one is 4, 12. If you are seeing this relation, there is not any element where A belongs to the R. That means 1, 1, 1, 2, 2, 3, 3. There is not any kind of element. So this is not a reflexive relation. Now go on to the symmetric. 1, 3 belongs to R, but 3, 1 is not belonging to the R. So this is not a symmetric. 1, 3 belongs to R, 3, 9 belongs to R, but 1, 9 is not belonging to R. AB, BC, but AC is not belonging to R. So this is not a transitive relation. So what can we say that? We can say that this relation is neither symmetric nor transitive, also not a symmetric, reflexive, sorry. So we can say that in simply we can say that this relation is not a symmetric, not a transitive, not a reflexive. Okay, now we are going on to the second question. Relation R in the set of natural number defined as R equal to xy, y equal to x plus 5 and x is less than 4. There is now a relation defined on the set of the natural number. As you know that what is the meaning of the natural number? Natural number are starting from the 1 and goes to the end, because we can't include infinity in it, because we can't know about the infinity. Infinity is a non-defined number, not a defined. Okay, so here there are relation we have given y equal to x plus 5 and x is less than 4. So how can you write the relation for it? So from here now I am writing the relation for it. Suppose, yes, I am taking the page, extra page here and writing the relation for it. Suppose it's a black and what is the meaning of it? The relation is given as y equal to x plus 5. Y equal to x plus 5 and x is less than 4. Relation is given as r equal to xy such that y equal to x plus 5 and x is less than 4. This is the relation we have given as. Now we have to find that in this relation we are putting the values of x, different values of x, and we will got the different values of y. So here I am putting values of x is less than 4. So first natural number is less than 4 is 1. Then we will put x equal to 2. Then we will put x equal to 3. If I am putting x equal to 1, so y equal to 1 plus 5. Y equal to 1 plus 5 is 6. 6 is a natural number. If I am putting 2, so 2 plus 5. So y equal to 7, natural number. 3, so 3 plus 5. Y equal to 8, natural number. The first one is 1, 6 belonging to relation. 2, 7 belongs to relation. And 3, 8 belongs to relation. So from here what can we say that? We can say that there are 3 elements. Now we have to check is this relation is reflexive, symmetric or transitive. So first one you will write the relation in the roster form 1, 6, 2, 7 and 3, 8. After putting all the elements in the relation in the roster form, we can see that 1, 6, 2, 7 and 3, 8. There are not any kind of element where A belongs to R. It means 2, 2, 3, 3, 1, 1, 6, 6, 5, 5. There is not any kind of element. So this is not a reflexive relation. Now go on to the symmetric relation. So as you know that about the symmetricity, in symmetric relation what should be there? There should be A1, A2 belongs to R. Then A2, A1 also belongs to the R. If A1, A2 belongs to R, then A2, A1 should also be belongs to the R should also belongs to the R, but there is nothing kind of this kind of condition here. 1,6 is belonging to R, but 6,1 is not. 2,7 is belonging to R, but 7,2 is not. 3,8 is belonging to R, but 8,3 is not. So this is not a symmetric relation. Also go on to the transitive. Then in the transitive condition is that A1 A2 belongs to R, A2 A3 belongs to R, then A1 A3 should be belongs to R. That means if AB belongs to R, then simply we can write also as BC belongs to R. Then in this condition AC should also be belongs to the R, but there is nothing any kind of condition. 1,6 is belonging to R, 6 nothing, there is nothing any kind of element. 6 7 or more than 2 7, but 7 is nothing. 3 8, but 8 is nothing neither. So we can say that this relation is not a reflexive, not a symmetric, not a transitive relation. Now we are going on to the third one question. Now there are two more conditions. First one, relation R in the set A as y is divisible by x. So first and second, third and fourth one, do it in homework. Do this in homework. First of all, you have to find a relation, write in the roster form, then check is this relation is reflexive, symmetric or transitive. If not, then you have to write down the condition why this is not. If yes, then you have to prove that why this is reflexive, symmetric or transitive. Thank you guys. I hope you like this video. Share and subscribe my channel. We have just in this video we have just gone through the basic. We have just gone through the what is the meaning of the relation, what is the meaning of the reflexive, symmetric and transitive, and we have just take some kind of example, some kind of question about the reflexive, symmetric and transitive. From tomorrow onwards, we will go on to the main question of reflexive, symmetric and transitive, and that kind of question always put up in the board examination, RBC as well as in CBSE. Maybe some question is put up in the RBSE examination, some question is put up in the CBSE examination. The level may be vary, but the question will be put up, it is must. So you have to be gone through all this topic, all the things, and you have to be pay your complete attention here. If you are not paying your attention on this topic is very important, because this topic is the theoretical topic, and theoretical topic you have to be just pay your fully attention. If you are not paying your full attention here, then you may just miss the things, and if you are missing the things, then you can't get the full marks in this kind of topic. So today I'm stopping my word here. From tomorrow onwards, we will start this lecture from this question. These two questions are in the homework, so try to do this, okay? And I will explain this, the fourth one question, on the next lecture, okay? And if you have nothing knowledge about the relation and function, just go through the video on the relation and function of class 11. Just go to the basic of class 11. What is the